Hello, my name is Timothy. Tanisamea niko na homa. Now, we want to understand the acidic dehydration of tetracyclines, and in this case, the example that we're going to use is chlorotetracycline. So we have two examples, chlorotetracycline and demeclocycline. And chlorotetracycline undergoes an acidic dehydration to form anhydrotetracycline. But let's understand the mechanism. So the first step that's involved, number one, is carbon number 6. So the carbon number 6 has what we call a bezylic hydroxide group. Carbon number 6 and carbon number 5A are important in this process. So the first step that happens is that this hydroxyl at carbon number 6 undergoes protonation. So protonation is addition of a proton. So when you add a proton to hydroxyl, it becomes a water molecule. So it becomes a water molecule, then it becomes then a living group. Okay, so it becomes a living group. It becomes a living group, a water molecule which is a living group. So if it's a living group, then it lives. Okay, in layman terms, it lives. And then after leaving, now the second intermediate that we form is what we call a carbocation that is tertiary. So what does tertiary mean? That this carbon is attached to three alkyl groups. So three alkyl groups. So you can see this alkyl group is a methyl. This group is from this side and this group is from this. So this carbon is positively charged. Okay, this carbon is positively charged. So because the carbon is positively charged, this carbon is tertiary, and something important to note is that this carbon is stabilized. It's a stabilized carbocation which is tertiary, attached to three alkyl groups. We shall see the difference with the demeclocycline, which the carbon is a secondary carbocation instead of a tertiary carbocation. So what happens is that the next step involved is the loss of a proton from carbon number 5A. So this is carbon number 5A. This is carbon number 5A. So what does loss of a proton mean? Loss of a proton means that it loses hydrogen. So when there's loss of a proton, loss of a proton, then what happens is that we now form a double bond, which is an alkene group. Now the double bond is formed here, and this becomes a double bond at this position because we want to stabilize this carbon. So this double bond forms at this position, and now we form an tetracycline. Yes.